Today we're going to be talking about a very interesting topic that it's called MCP. But our topic for today is going to be understanding the model context protocol in AI. So we'll consider this to be the future of AI at the moment. So let me just quickly introduce myself. So my name is Jude. I'm a data engineer at Unicorn Group of Companies. So basically, what I do is to build data pipelines and AI systems, and then handling some of our optimizations and deployment as well. So, so today, like I said, we're going to be looking into one of the buzzwords in AI in recently. So the model context protocol, it was recently released this year. So let's between large language models, choose agents and memory systems. So let me kind of paint you guys a picture. You know that when people hear MCP, some people will be wondering like what was the concept behind this. So let's take for instance, like you have a website. Usually websites, when you're accessing a website and then you're trying to access data, all those exchanges of data that goes across website, all those are being done via HTTP request. So for those who do front engineers and back end engineers will definitely understand what I'm talking about. So you sort of have all these HTTPS protocols, like you want to invoke an endpoint to get access to your data. Those are how the website works in real sense. So now, for the MCP part, MCP is something like just consider that to be uh, uh, an endpoint, another protocol, but in this case, it's no longer like this one is different because it's now more like it was built specifically for AI models. So the MCP there is like an endpoint you can actually call, and then it's going to like get you access to your AI agent to like do some basic functions for you. So, but we're going to dive deeper into that as we go on. So, let's look at the problem. So now another question there is that the people who released this MCP actually are supposed to mention that in the LSD, the previous slide. That's the Anthropic. I don't know if there's anybody here who have used cloud AI before. So the cloud AI, the producers of cloud AI are the people who manufacture this MCP. So this the like I said, it was released this year, and that you can it's Anthropic. You can search them up and also get to read more about the company and what they are into. So since the release, it has actually been changing the way AI system is being integrated across different sectors of the organization. So now the problem, what are they actually trying to address? Because one thing with technologies is that you don't just send out, like, should I say, release frameworks without that framework actually solving a particular problem. So now the MCP, it's solving a lot of problem. Like I said, let's look at them one after the other. So it said today AI consists of many disjointed components. Let's see, LLMs, memory systems, tool chains, and agents. So each vendor uses proprietary formats and context representation, and this leads to inconsistent context handles between tools or models. Then vendor logging due to closed memories and state systems. So let's look at as for the second part, which is the each vendor uses proprietary format and contextual representation. This is something that because our company is also very much data driven and also AI driven. So most of the AI let's take for instance the time we're building our my smart medic, which is also AI focused in a way. So we actually stumbled upon this problem at some point. So the vendor uses proprietary format is kind of let's say you have different AI agents. You have cloud, you have open AI, you have Gemini and stuff like that. So what happens there is that the way Gemini, let's say Google might decide to design their own model, the way it handles messages, the way it stores messages in its history and all of that. It's not going to be the same way as OpenAI does theirs. So everybody has to, like, do things the way it's going to fit them, the way they feel is best. So I can remember then we were trying to work when we're trying to log in our message history. So like how users interact with our model, we need to store those information in our database so that when the user visits again, the model should be able to at least understand it should be able to summarize the message history and at least have context of what the user or who the user is and all the questions the user have asked in the past, and be able to, like, make sure that session doesn't go out of context, basically. So in that case, we were trying to use MongoDB for that. So what was the issue we encountered? We discovered that at that point, I think we're using Llama. I know we experimented on so many models. I think we're using Llama at that point, and so we discovered that the way Llama is actually structured, it doesn't fit into the MongoDB backend in terms of like message retriever, that's conversational retriever capabilities. It doesn't fit in. So it made us to like move away from that. So that's that's what this is. This is the one of the big problem why MCP, the big problem that MCP is actually trying to address. It doesn't want you trying to, like, because you're using this model, you have to like create a custom solution. Everything becomes a little bit hacky and redundant. And not just redundant, it becomes more tedious, because if you're having multiple AI agents like OpenAI, Gemini, you're supposed to like create custom integration for each and every one of them. So this is what the actual problem that MCP is trying to like take away, so that it makes everything easy. So so moving to the next one. So now the technical challenges without MCP. Now it's you have to experience like lack of standard formats for representing agent states, memory, and task history, just like I mentioned earlier. Then reinventing serialization and storage formats for each use case. Then difficulty in composing agent tools, chains from multiple providers, just like I mentioned, where you have OpenAI, Gemini, Cloud, and so many other big AI agent companies that you want to integrate. Then non-transferable memories or histories between models. So now the thing is that, like I said, for everything that you want to do, if you want to do multiple AI agents, which is actually the order of the day, people don't want to rely on just one agent. They want to have multiple AI agents to do a lot of things. Maybe this will send to the other one, this one, like doing different tasks. Basically, this one will perform and send to the message, the context to the next AI agent. Okay, I've done this. You should pick this from there and do. So that's the way it works. So now, without MCP, you have to keep reinventing the wheel. You are also like you're creating custom solutions for everything. So MCP like gives you a boilerplate, like let's say it's standard. You just need to like integrate, and then everything you can see everything is connected together. Because currently the approach we're using is that everything is decentralized, but MCP tries to unify everything in a I wouldn't say it's tight coupled. It's just like it unifies all the whole systems and tries to also reduce latency, basically. So let's go to the next slide and talk about the architecture. So I believe the architecture will also help us. We are all engineers, right? So the architecture should also help us understand how it actually works behind the scene. So now, for the MCP, when you talk about MCP, you have to consider three different components, basically. So MCP has the MCP server. So here we have the MCP server, you have the host application, and also what the client layer. So anytime you hear MCP, three components should come to your mind: the server, the MCP server, the client, and then the server layer. Sorry, the host. Sorry for that. So now let's take a look at what's actually made up of what's that actually supposed to be in your MCP server. So now in your MCP server, you're supposed to have things like resources. So the resources there you should be talking about, let's say you want your AI agent to have access to your database. So resources could be anything, but I would liken it to something like database. if you look around, there are lots of products out there that's built on top of MCP. People are already developing text to SQL kind of thing. And the reason because of that is that it wants to take away the technicalities in, like, maybe when you want to query your database. So what it does is that I'm just trying to give you an example of a product that uses this MCP. So you have an interface where you can talk to your AI agent and just be like, because usually data analysts, what they do, and sometimes data engineers, they write SQL queries to get information, to get metrics, KPIs from your database. What I mean by this, like, let's say you want to get information about your finance analysis, maybe revenue generated per month, yearly, all those KPIs that are usually tracked within your database. So now they developed a system whereby they can only use a normal text, just the way you chat with your ChatGPT. Tell it, please get me information about how much have you generated in the month of February, just like that. Now your AI agent is going to run the SQL query behind the scene, right? And then get those information. That's just the resources I'm talking about here. So the resources there is standing, could be your database, could be any other, maybe file system, it could be anything. So now you have the tools. So the tools is more like a couple, like something you use to couple your how should I put it? If you want to, let's say it could be different, because the server could contain different data, to also contain different information. So tools could be in anything. Let's say you want your AI agent to have access to weather data, you can configure that into your tools. You want it to have access to, like, let's say, information about the Slack, GitHub, Microsoft, all those things could be tools. And you can have thousands of MCP servers all connected together, right? So you have the context, then you have the prompt. So the prompt there is something that also instructs your AI agent. It could be individual, or it could be depending on the level where you want to define your prompt. So kind of telling them, okay, this is what I want you to do. This is how I want it, just like setting a standard workflow for your AI agent to follow, right? So then you talk about the protocol layer. So like I said, protocol layer, once you hear about protocol layer, what comes to your mind should be like endpoint. What part of the AI agent do I want to invoke, right? So you have to look at the protocol layer as your endpoint that you want to hit. Or let's say I want to call the AI agent about the weather. Let it tell me if it's going to rain throughout today, stuff like that. So the AI agent already have those information in the tool. Maybe sourcing it from the internet, this could be anywhere, or maybe a database where it have all those weather forecasting information. So once you invoke it through the protocol layer, it gets you that information and respond accordingly. Then another thing we also like to point out is that the way it was designed, the MCP was designed to function like the JSON RPC. This is more like the transport layer, how you send your data, right? How do you send it, how you transform your data from one prompt to another. So it makes it more scalable. We'll actually come to that later on. So this is all about the MCP server. Now, like I said, MCP server could comprise of many tools. You can have thousands of MCP server, Slack, GitHub, Jira, and as many as possible. It was not possible before, but this is what MCP gives you, right? So now you have the next one is your MCP client. Your MCP client is usually bootstrapped with your application. So what do I mean by this is that you may have thousands of MCP servers, right? All this will be unified just from a single MCP client, which is connected to your protocol layer. So once you call to your MCP client, it communicates to the protocol layer in the sense that which of this AI agent does this guy want to talk to is going to invoke it, and then to respond through the MCP client. And the MCP client also return that response to your host application, right? So the MCP client now connects to the protocol layer and then the transport system. This transport system, I would love to talk about it, but I think it goes way beyond the scope of this presentation. I just wanted to like give us this presentation on a high level, right? So that is when you're going deeper into the maybe the implementation strategies that you can actually follow. Like you see that the transport layer, it has the XTDIO transport and the HTTP via the server-side encryption strategy. So I will just share briefly what it does for people who might want to like try it out. So now, for the STDI transport system, the way it works is that now for your MCP servers, if you have your MCP server, like you've defined, let's say, let me start from a single MCP server. Let's say I want my GitHub. Let me try with GitHub. I want my AI agent to actually have access to my GitHub repositories, and then all my code, all the pull requests that has been raised, all the what else? Merges, all this activity that happens on GitHub. It's easier for me to integrate that as an MCP tool. I just need to connect some APIs, right? And then give it access to everything that is happening on that GitHub. So I could decide to run this MCP server as a local service on my host machine. This is when I can actually use STDIA transport system, because I am actually the one managed. I would just consider it to be a self-managed service that I'm handling, right? So that, because I'm running that as a local system on my, then I'm going to specify, okay, let it run as an STDIA transport. Then for HTTP SSCE for server-side encryption, this is mostly for cloud-native application, because if you look around, you can see that since the release of this MCP, a lot of product has emerged, and not just that, a lot of it has opened a lot of possibilities. Just recently, we have Amazon released is it S3 Vector? That's for vector database. So a lot of people are doing so many things. And for this SSC transport system is like when you want to integrate it with other cloud native technologies, like let's say Lambda, you have your Google Cloud Functions, Azure Functions, you can name them. There's so many, because those ones have the capabilities to like scale elastically. Let me just put it like that. It scales as much as your workload, it scales as well. So that's what I mean by elastic scaling. So I think we've spoken so much on this architecture. Let's zoom in a bit on how this looks in real time, like in the real sense. So now, if the previous diagram actually confused you, I believe this should actually give you an insight of what it means basically. So you have the MCP host, right? And then you have the MCP server. Like I said, MCP server contains your tools. It could be your GitHub, it could be your Jira, it could be your Notion page, it could be anything. It contains a lot of resources that is needed. This is what matters the most. If you want your AI agent to be optimal, that means you need to like spend a lot of time to make sure that you have a very robust MCP server, because this is like the back end that ties everything together, right? So then from the MCP server, you can see it's connected to the database, it's connected to other external applications, like you have the Google Chrome, which is being put from an API, you have the file system. So all these things are being connected to the MCP. They are connected as different tools. Database is a different tool. External apps, Chrome, Google Web Searches is also a different tool. File system is a different tool. And then the prompts, like I said, the prompts kind of instructions on how to like carry out task. Then the MCP server is now like the MCP host, is now like your client that you interact with. In this case, just like assume it to be your ChatGPT web UI, and that is what this cloud is replacing. And then you have your IDE. Your IDE are like your VS Code, your Cursor, your whatever it is. All those things have AI agents integrated in them. That's why these days when you're coding on VS Code, it tends to like, suggest for you the next line of code you should write. All this like AI doing all of that within the backend, and MCP actually made those things possible. So this is just what MCP looks in real sense. So now let's talk about the evolution of MCP. So the historical context of evolution of MCP. So the modern context protocol began as a framework to exchange AI interactions. So like I said, it's just for like AI agent B will interact to AI agent A, and then that was the way it was actually meant to function. But the current state now is that today it facilitates seamless integration across various applications and services. Everything has been made easier Like, you don't have to go and start reinventing the wheel. Everything has been, you can have a single MCP structure. Today, you can easily update. All you're going to be doing is just be pushing in different MCP servers. Mind you, your MCP client is there on standby. Your host is there on standby. So you just need to, if you need, let's say, another additional agent to do a few things, you can just push the tool to MCP server and then wrap it up with a transport system. It is going to pick it up, and then you have a fully functional AI agent that your users can actually access. So let me also paint you a picture. Recently, I worked with a company that there was something that we were trying to achieve. It was a multi-AI agent system. So we want to, just to give you context of how things has evolved, like there is endless possibilities of what you could achieve with it. So the goal was for us to like have an AI agent for a back-end developer, front-end developer, UI UX developer, so many of them, even data analysts. So this is not like saying that it's going to replace people who are doing backend. No, the goal was for them to like give us a boilerplate, right? A boilerplate that it's going to understand. It's going to understand the services, and then it's going to. Although there is also something like a graph database in between that we're using to like map entities together. So you have endpoints, and then you can have services that relate to different endpoints, methods, just like using LangGraph. If you use LangGraph, or maybe you've heard about LangGraph, you already understand the part what I'm talking about. So it's kind of map entities together. You can have services that are connected to different endpoints, and the method that are connected to different services and endpoints, like graph that makes it goes way beyond. So the thing is that the backend AI agent is going to create a boilerplate and send those information via the schema of that boilerplate to the front-end AI agent. The front-end AI agent is going to also create something that is very compatible with what is in the backend. So these are like boilerplates, right? So for the developers, it tends to speed things up for them. Everything is already there. So what you're doing basically is to put things together. So you have templates to follow. So that was the goal. So if you're thinking maybe is it going to replace? No, it's not about replacing. It's about making developers work faster. So this is just to paint you a picture of the level where we are getting to. So to tell you that actually the future of AI is it's really very bright, so to speak. So so the future of implication, the protocol will drive innovations and development leading to smarter systems, which I believe we are getting to. So, so then the benefit of using model context protocol, like I said, it enhances scalability to support growth, provide flexibility for diverse applications. Like before, it was not possible to connect OpenAI, Gemini, and the cloud, all those things together for them to function optimally and maintaining the same context. But now it's very possible. So ensures interoperability across systems, then boost efficiency in processing models. So these are already things that already discussed. Then let's talk about the applications. Where this MCP, I know that AI agent is being used across multiple industrial domains, like the healthcare agents, healthcare domains and the finance. But the goal now is this: if you're using a different architecture, and with this MCP release, do you think it's something that can actually help you scale? If you have maybe a company that is focused in AI, of course, yes. So you have every right to like, if you don't want to bore your engineers or maybe make them feeling burnt out, this is the kind of framework you need to introduce to them, right? So that instead of doing things repeatedly, every time you want to integrate a new solution, this makes you like you're focusing on the important things. So you have this. The application goes way beyond just healthcare and finance industries. So it can have it anywhere. And then so the effective comparison, we'll just quickly go through the differences between the traditional models and the model context protocol, the way we've done it before and what it is now. So before, we focus on specific data sets, predefined outcomes for traditional models, like I mentioned. Then for the intersection between both is that Yes, they have the ability to adapt and optimize based on context and real-time data in both approaches. But then for MCP, you can now have everything is a bit dynamic. Then there is a context awareness. The processing, that's the context awareness that is in the model context protocol. So all those things has been made seamlessly possible for you to like have all your systems well integrated and connected together. Then okay, so then evolving trends in the technology. So you have leveraging real-time analytics for better decision making, shared data access, which is what MCP gives you. So one agent can actually get information from this data and can actually pass it across to the other ones, and that context will not be left from there. So we have seamless connectivity between various AI agents, frameworks, and models, and then enhanced interoperability, and then integration with cloud-based data processing solution. This is also a very important aspect that I feel that is not actually being talked about enough, or maybe we're not just seeing it. So having those AI agents integrated with cloud platforms is like, it's massive. Like when I mean it's really, really massive, because cloud allows you to like, you can scale to any length you want to, no matter the volume of your customers, you can scale. That's why they said it's elastic scaling. So it can accommodate as your users grow, or maybe as the workload increases, it tends to accommodate all of that. So then